In this video, I'm going to show you how you can go ahead and write an equation that's parallel to a given equation or perpendicular to a given equation. Now, first of all, I want to start by just talking about the difference between parallel and perpendicular lines. Parallel lines, they never cross. And another thing is if you have multiple equations and they represent parallel lines, they will have the same slope. And that's represented by the letter M. Now, when you have perpendicular lines, they will not have the same slope. They will have what I call the opposite, and I'm going to put a negative sign to represent opposite, reciprocal slope. So what does that mean? Well, that means if our original slope was 3/4, then the line that's perpendicular to it would have a slope of negative, because it would change from a positive to a negative, and then it would be the reciprocal, which means the 4 goes to the numerator and the 3 goes to the denominator. So if a line were perpendicular, if its slope was 3/4, the line perpendicular to it would have a slope of -4/3, and vice versa. If they gave you a line that had a slope of -4/3, the line that's perpendicular to it would have a slope of 3/4. Going back to the parallel, if they told you that the first line had a slope of 3, then the second one would have a slope of 3. So just keep that in mind as you're doing these, because that's going to make a difference in how we approach the problem, whether it's a parallel situation where they have the same slope, or it's a perpendicular situation where they have slopes that are going to be the opposite reciprocal of one another. So let's go ahead and work out a problem to see how we can put this into action. Notice in this problem it says find a line parallel and a line perpendicular to the given equation that passes through 2, -2. So right here is our given equation, 4x plus 2y equals -4, and that passes through point 2, -2 on a graph. The first thing that we want to do, if we're not given this equation in slope-intercept form, and when I say slope-intercept form, I mean y equals mx plus b, then we want to go ahead and we want to convert this to slope-intercept form to make sure that we got the right slope. Don't just pull the number that's in front of x. Go ahead and convert it to make sure that you have the right slope. So I'm going to go ahead and just draw a box over here on top where we're going to do the work. And I'm going to write first. So I'm going to take 4x plus 2y equals -4. And we're going to go ahead and change this to slope-intercept form. So to do that, what I want to do is I want to go ahead and move the 4x over to the other side of the equation. So I'm going to subtract it using inverse operations to move the entire term over to the right. It cancels on the left, and what I'm left with is 2y is equal to -4x, because I'm just bringing that down, and then I'm going to bring down my constant at the end, -4. Now we're almost done, but don't stop yet. In order to have this in slope-intercept form, we got to have it looking like this: y equals mx plus b. That's what we want it to look like. So notice this y has a 2 in front of it, but we want a y with a 1 in front. So I got to divide out that 2. So I'm going to divide by 2 on all 3 terms. And I end up with y is equal to 2 will go into -4, -2 times. And 2 will go into this -4, -2 times. So this is my actual equation where I can get the slope from. So notice I have y equals -2x minus 2. This -2 now is going to be my m. I'm going to put an m right there. That is my slope. So now I know what my slope is for the given equation. It just took a little bit of work, a little bit of algebra 1. And I know this is the ordered pair. I'm going to label this ordered pair. That's my x1 value, and that's my y1 value. So now that I have an x1 and a y1 value, and I have a slope, I can go ahead and find a line that's parallel and find one that's perpendicular that passes through this point. So let me go ahead, and the way I'm going to do that is I'm first going to do the parallel line. I think it's the easiest one to do because we don't have to change the slope. We're just going to keep it -2. Now for this, we're going to use what we call the point slope form formula. And you learned it in Algebra 1 and Algebra 2. So it looks like this: y minus y1 is equal to m times x minus x1. And the letters, the variables I should say, that I put in pink are because we're going to replace them with the numbers. So now let's go ahead and let's substitute our values in for y1, m, and x1. So I'm going to rewrite this right quick. I have y minus, and I'm going to put a set of parentheses for my y1, equals, m is going to go here, so I'm going to leave a space, and then x minus my x1 value. And for that, I'm going to put parentheses. Now notice the only one that I didn't put parentheses is the m, and that's because it won't make a difference on the m. There's always just going to be a single value here. So now I'm going to substitute my numbers. My y1 value from the ordered pair that they gave me for the scenario is -2. So I'll put a -2 in there. My m value that we found when we converted the equation they gave us in standard form is -2. Right, that was our number in front of the x once we converted it to slope-intercept form. So I'm going to put a -2 here. And my x1 value is this +2, the first number in the ordered pair they gave us. So now what we're going to do is we're going to go ahead and simplify this by distributing the signs that we see. So don't distribute the slope yet. Always start out by just distributing the signs that are inside and outside the parentheses. In other words, this -1 times this -2 changes that sign to a +2. So now this becomes y plus 2 is equal to -2 times x, and this -1 times a +2 turns that into a -2. So see these changes that occurred? This now became positive, this 2 that was positive became negative, and now we do our final steps, which are we're going to take the slope of -2 that's on the outside of the parenthesis and distribute it to both terms on the inside of the parentheses on the right side of the equation. So this is -2 times x gives me -2x, and then I have -2 times -2, which is going to give me +4. And then I'm just going to bring down the left side of the equation. Now, while you might be tempted to stop there, we're almost done, but we do need to remove this 2 and have it go over here so that we end with an equation that's in slope-intercept form. So I'm going to go ahead and subtract 2, because here we're adding 2. And then I'm also going to subtract 2 from the right side. Now be very careful not to subtract this constant value of 2 from the variable. A lot of people will attempt to do that, but that'll mess you up. Now notice this has an x, so we cannot combine terms that are not like. Therefore, when you subtract that 2, it only subtracts from the constant value at the end. Now 4 minus 2 just leaves me with 2. I'm simply going to bring down my -2x. And notice I did put a plus sign in front of here because it's 4 plus -2. That leaves you with a +2 value. And then over here on the left, all I have left is just a single y. So now you can see I have y equals -2x plus 2. I'm going to go ahead and box it. And this line right here is parallel to the given equation and runs through to -2. So what I'm going to do now is I'm going to put it in my calculator and I'm going to graph both these equations by hitting y equals. And I'll type in the original equation that we found with slope-intercept form, put in slope-intercept form, which is y equals -2x minus 2. So -2x minus 2. And then I'm going to put in my new equation, which is -2x plus 2. And I'm going to graph both, and they should be parallel lines when we look at the image. And you can see those lines are parallel. Now the next thing I want to do is I want to check to make sure that this second equation, that it did go ahead and cross through to -2. Because if it doesn't, then I've done something wrong. And notice when I go to +2, and then I go to my y value for the second equation, it's -2. So it does cross through the point to -2. So I verified I did it correctly, and now I'm going to move to the next one. So we are going to find now a line that's perpendicular to this equation. And this is where a little bit more work comes in. We did talk about in the notes in the beginning, I said that when you had a perpendicular situation, unlike the parallel where the slope is the same, we have to have a 90-degree angle, right, where our lines cross, which means that the slope is going to be the opposite sign reciprocal. So we got to flip the numbers and change the sign. If it's positive, we change it to negative. If it's negative, we change it to positive. Well, in this case, my slope, I'm going to write it down. My original slope is -2. So I'm going to change the sign, which means it's going to change to a positive. And I'm going to do the reciprocal. Now, looking at this initially, you might say, well, Mr. H, what's the reciprocal of just 2? Because there's no denominator. Well, we have to turn this into a fraction. And you turn it into a fraction, the original one, by just putting a 1 in the denominator. And now if I wanted the reciprocal, I got to move the 1 up, and I move the 2 down. So in other words, it becomes 1/2. So this will be the slope that we're using to find the perpendicular line. We will not use the original, that's negative. We're going to use the reciprocal opposite sign, which is 1/2. So let's go ahead and we're going to write our formula. So I'm going to write y minus, now instead of y1, we already have the y1 over here. I'm just going to put parentheses for y1. And then that's equal to my slope m times x minus my x1. And I'm going to put those values in. Now for the y1 value is -2. So in place of y1, I'm going to put -2. For the m, the slope, our new slope is going to be 1/2. So I'm going to put that there. And for my x1, I just go to the x ordered pair that they gave us, and it's +2. Now we're going to do our initial step, and we're going to distribute. So when I distribute this negative to a negative, it changes that 2 to a positive. So this becomes y plus 2. I'm going to bring down my 1/2 for my slope. And then I'm going to distribute this negative to that +2. And that becomes x minus 2. The next thing I want to do at this point is I want to go ahead and distribute the 1/2 to both of these values inside the parentheses. So I'll have 1/2 times x, and that gives me 1/2 x. And then I have 1/2 times -2. And for that, right, if you're not good, right, if you start forgetting your numbers, you get confused, right, throw it in the calculator. So I'm just going to show you what I mean when I say 1/2 times 2, -2. I'm going to use my fraction bar, alpha y equals inner. I'm going to put 1/2 in there. And then I'm going to go ahead and multiply that times -2. And notice it gives me -1. So then I have -1. Now I'm going to put my equal sign. And I'm going to bring down my y plus 2. We're almost done with this problem. The next thing I want to do is I need to move this 2 over to the right side. The way that I do that is I'm going to use inverse operations and subtract that 2 from the left side of the equation. And then I'm going to subtract it from the right side. Notice I made sure when I subtracted it that I'm subtracting it from the constant value. That's a like term. I did not subtract it from the variable. So what I have left over now is I have y is equal to, and your slope just comes down with the x, 1/2 x, and -1 plus -2 is going to give me -3. So this line right here is going to be perpendicular. So I'm going to write underneath it, perpendicular to the original equation. Whereas this equation we found over here had the same slope, and it was parallel to the original equation. So I'm going to go ahead and get my calculator real quick. I'm going to graph both of them. We already have the original equation in, -2x minus 2. I'm going to go ahead and type the new equation in. So alpha y equals inner, 1/2. I'm going to go ahead and put my x and -3. Hit graph, and when it graphs these, we should see that they're perpendicular and they make a 90-degree angle. And there it goes. You can see it crossing right there. Now I do want to check the line. using second table to confirm that it does go through point 2, -2. So when I go down to 2, notice that it does cross through -2 for the y value. So I know that I've done it right. And that's all there is to it.